Okay, we're going to be taking a look at 5.4. We'll be learning the quotient property of exponents. Quotient means to divide. So we're going to learn what do we do with exponents when they're dividing so that we can simplify an expression with exponents. And you'll know you can do it when you can write an expression in its simplest form. So 5.1, we covered product property, and that was when you have two exponents. So I'm just going to do like a little side note here. When you have like x to the third times y to the fourth, actually we're used to seeing it like this. And then we could say like times 2x to the fifth y to the second, right? And we would take then our base numbers. So if there's no base number here, it's just a 1. So 1 times 2 is 2, or we could just say there's no base number, so we're just going to rewrite. There's no base number to change our 2, so we're just going to rewrite our 2. And then x to the third and x to the fifth, we would count them up. 3 plus 5 is going to give us x to the eighth. And then y to the fourth and y to the second, and we add them up. 4 plus 2, and that's y to the sixth. We also learned about negative exponents, and that's like if we have 2x to the negative third, that means that this x to the negative third is in the wrong place. It's all sitting over 1, so in order to write this with all positive exponents, which is simplest form means all our exponents will be positive, we move our x to the negative third downstairs and it becomes positive third. So we change the sign by moving it in the fraction. And then the last thing that we learned, this was 5.3, was raising a power to a power, or the, raising a power to a power. So that would be like if I had 2x to the third, y to the fourth, and that was all being raised to the, fifth power. So each individual piece, 2, because this means there are 5 sets of this whole thing. So there would, if I were to expand it out, there would be 5 2s, so I would get 2 to the fifth. There would be 5 x to the thirds, and there would be 5 y to the fourths. So we're multiplying our exponents together. So 2 to the fifth, if we were to work that out, it's 32. And then 3 times 5 is a total of 15, and 4 times 5 is a total of 20. So that was product, or raising a power by a power. So think about this, and I just kind of went over it, but a number to the exponent, so a to the n, so any number raised to a power, is telling you to use the base in multiplication n number of times. So let me just kind of show you a clear example. And this works with numbers and variables. So I could say 2 to the fifth, and that is telling us that we are going to take 2 and multiply it 5 times. Oops, I said 5. 2 times 2 times 2 times 2 times 2. Same thing is true of like x to the third. That's telling us to take x and multiply it 3 times. Okay? So when we're working with that and we have different values, so like let's say we have x to the third times x to the fourth, when we multiply our bases, so when we're multiplying common bases, we add our exponents. So our shortcut here is 3 plus 4, which is 7. When we divide, we are going to subtract our exponents. So multiplying bases meant we added our exponents. We did x to the 3 plus 4. When we divide, we are subtracting bases. We're saying x to the 4 minus 3, which is x to the first. Okay? And I'm going to show you some kind of tricks and things that I do. But if multiplication is to adding powers, then division is to subtracting powers. So when we multiply, we add powers. When we divide, we subtract powers. And it makes sense. Multiplication and division are opposites. Adding and subtracting are opposites. So let's look at some examples, and I'll kind of work through these. You'll see I've pulled examples. These are just screenshots from Delta Math itself. Oop, and I'm moving this one around. Not sure where. This is exactly what you'll be assigned, which is nice, okay? So what I'm showing you here is what you're going to be working on in Delta Math as they give it to you. So we always want to first reduce bases if we can. So the same way we would always look to multiply bases when we were multiplying, we look to reduce bases if we can. So I have 20 divided by 4, 20 over 4, and these bases reduce. It depends on how you like to write it. I like to write another fraction line, and I'm going to say 4 goes into 4 once and into 20 5 times. So I get 5 over 1. So there's my reduced bases. So now I'm looking at my x's. I have x to the 4th, and remember this is x to the 1st. There's a 1 there, and if it helps you write it in. And all I do, because think about it like this, I'm going to move over here. This is saying there are 4 x's on top, multiplying, and there's 1 x on the bottom. If I were to expand this out, so if I just took this x to the 4th over x to the 1st and expanded it out, this is what I'm looking at. And every x that you have on top cancels out with an x on the bottom, vice versa. So here I have an x on the bottom, so if I cancel out 1 there, I can cancel out 1 there. And I'm left with 3 on top where my higher exponent was. So I had an exponent of 4 here and 1 here. And 4 minus 1 is 3. I guess we're used to seeing it like this. 4 minus 1 is 3. So I'm left with 3 x's on top. So I'm going to say 5 x to the 3rd. There's 3 on top. And I'm doing the same thing with my y's. I have 6 minus 3. 6 minus 3 gives me 3. And my bigger number is on top, so I'm going to write my answer back on top, y to the 3rd. So then to type your answer in, we have 5 x to the 3rd, y to the 3rd. You don't really have to put it over 1. So in orange here, I would hit 5. That would be the first thing I do. And that would give me a 5 here. I would say x to the 3rd, so I'm going to say x, which would make an x here. And then I'm going to hit my a to the b button. That's going to make an exponent. So that moves my cursor up top here for my exponent. And then, that's a cursor, not a 1. And then I'm going to hit 3. And then I have to hit the right arrow button. Remember, I've got to bring my cursor down. If I hit, so to get 5x to the third, I did all of those things in orange. That was the first button I hit, second button, third button, fourth button that I hit, okay? In a different color, I'm going to do y, and that would give me a y. And then I have to make my exponent, so I'm going to hit a to the b again. And then I'm going to hit 3. And then you would hit submit answer. Okay, so that's the most in-depth. I'm going to go over how to punch those numbers in. If you need help in class, just ask. Okay, let's take a look here. So I always first look to reduce my base numbers. So I have 16 over 8. This really means divided by, so 16 divided by 8. So if you know that that's 2, you can do it like that. If you have to reduce, you say 8 goes into 8 once, 8 goes into 16 twice. So it's 2 over 1. I'm going to take a look at my x's. I have x to the 7th and x to the 4th. So what I'm not going to do, I'm not going to do 4 minus 7 and get negative 3 and then move negative 3 from the top down. Your best way to do this is to always use your largest number. So we're going to say 7 minus 4. And that, we're really working with x to the 7 minus 4. And that really equals x to the third power, right? 7 minus 4 is 3. But where did I have more x's? I would have run out of x's here, and I would have had plenty of x's left over down in the bottom. I would have had 3 x's left over down there. So I just do big minus small, so 6 minus 1 is 5. And I have more on the bottom, so this is going to be y to the 5th. You should only have one of each in your answer. So here's how we would type this answer in. I guess I will show you how to do the fraction one. Not quite as in depth though. So let's see. I would hit 2. Then I'm going to say divided by, because there's nothing else on top, and that's going to turn this into a fraction. In here it'll get bigger, and then you got a fraction bar. And then I would hit x raised to the third power, and that's going to make x to the third. I have to hit my right arrow button, and that's going to allow me to then hit y raised to the 5th power. It's going to be y raised to the 5th power. So dividing powers, all we really have to do is subtract. We're going to subtract big minus small, and then write our answer on either the numerator or the denominator, so the top or the bottom, depending on where the bigger x or y value was, wherever the one that had the biggest exponent. So for this one, without doing any work, I know that I'm going to write my answer in the bottom for x. And for this one, I'm going to write my y answer in the bottom as well, because 7 is bigger than 2 and 5 is bigger than 1. So 7 is bigger than 2 and 5 is bigger than 1. So I know, just based on which ones are bigger, where my two answers are going to go. But let's work through this. So 8, I'm looking, can 8, is that being reduced by anything? It's not, so I'm just going to rewrite it where it is. Okay, then I'm doing 7 minus 2, which is 5. And I'm doing 5 minus 1, which is 4. And that's our answer. So I would hit 8 divided by x raised to the 5th power, right arrow, y raised to the 4th power. Okay, reduce bases, or reduce our base numbers. So 8 over 2, and these reduce. 2 goes into 2 once, and 2 goes into 8 4 times. So I'm left with 4. And then I have 8 over 6. So I have 8 minus 6. Remember, I can write both of my answers are going to go on top without doing any math because that's bigger than that and that's bigger than that. So my x, I'm doing 8 minus 6 to get 2. My y, I'm doing 7 minus 6 to get 1. I didn't have anything else to write in the bottom, so it's technically over 1, or I could just leave my answer like that. Okay, this one, reduce my base numbers, which is 9 goes into 9 once, and into 27 3 times. Before I do any work, I can tell that my x answer and my y answer both can be written on top. Just from comparing my bigger exponent is on top, so I'll have leftover there. My bigger exponent between these is also on top, so I'll have leftover there. So now I have 3 over 1. I'm doing 5 minus 3 to get 2. And again, 5 minus 3 to get 2. Okay, last couple examples. Okay, so this one we can reduce. 4 goes into 4 one time. 4 goes into 8 twice. Now I'm looking, I can tell my x's. My answer is going to be written on the bottom. And my y's, neither of them are bigger. In fact, if we were to subtract these ones, they cancel each other out. I would get 0. So y to the 0 power, I don't need to write an answer in for that. So I have 1 over 2, and all I'm doing now is I'm saying 6 minus 2, which is 4. So 1 over 2x to the 4th, I would say 1 divided by 2x raised to the 4th power. And this will be our last example. Okay, 16 over 24. So we can reduce, 8 goes into both of these. 8 goes into 16 2 times, and 8 goes into 24 3 times. So I'm going to get 2 over 3. I'm looking at my x's. I know that I'm going to have an x answer in the bottom because my x is bigger. And I know that I'm going to have a y answer in the bottom. So x answer on top, y answer on the bottom. I know my x goes on top because it's bigger on top. I know my y goes on the bottom because it's bigger on the bottom. And then I'm just subtracting. So I'm saying 5 minus 4 and 8 minus 3. You always do your large number minus your smaller number. And then for this one, you're going to get 2x to the 1st divided by 3y to the 5th. So again, here's how I would have hit those numbers in the calculator or in the keyboard for the answer. 2x, you don't really need to raise it to the 1st, but if you want to, you'd say to the 1st power. Then you're going to say divided by to get your fraction line, and then you'd say 3y raised to the 5th power.